Well, hello again, everybody, and we are in our discussion of empirical formula. So let us jump right into this next question. Consider a compound containing 50.70 grams of iron and 46.30 grams of sulfur. What is the empirical formula? Okay, we're looking at empirical formula again. Now, let us go back and check out our notes here about empirical formula. Oh, hey, there it is. It's in blue, isn't it? Empirical formula. So what is the empirical formula? The empirical formula is a formula for a compound showing the smallest whole number mole ratio. That's what we're looking for. Smallest whole number mole ratio. What's the process? Usually the problems are of two types. They either give us a percent or they give us a mass. If they give us a percent, we want to assume 100 grams. Then we want to calculate the grams of each component, calculate moles of each component, and then set up a ratio, putting the smallest moles in the denominator so that we have a whole ratio, we hope. And if we don't have a whole ratio, if we have something that turns out to be 1.5 to 1 or 1.3 to 1, we have to multiply by 2 over 2 or 3 over 3 until we do get that whole number ratio. Good. Now, what happens if they give us mass? Well, really, if they give us mass, it's easier because we don't have to do 1 and 2. Those no longer have to be done. If they give us mass, we go right front to 3, and we do 3 through 5, or 3 through 4, and that is all there is to it. So once we give in mass, we calculate moles, and then we set up our ratios. That's all there is to it. So let us jump into that. Here we go. I have a compound, 50 grams. Okay, what do I have? Iron. So I know I have 50 grams of iron. I want moles of iron. So I'm going to take 50.70 grams of iron times what? 1 mole per. Let's go to our periodic table. Yoink. And where's iron? 55.85. 55.85 grams. And what do I get? Use the magic TI30XA, and what do I find? 50.70 divided by 55.85, and I get 0.90778, right, moles of iron. Now we don't want to round here. Remember, we want to round. We really don't want to round at all in this until we get to the very, very end, and then we don't want to round much. So don't round this first number. Moles of sulfur, yoink, is equal to what? 46.30 grams of sulfur times 1 mole of sulfur per what? Sulfur, sulfur, sulfur. Zoop. 32.06 if we go to 4 sig figs. 32.07, right? I had to say 06, 32.07. Good. 32.07 grams. And what do I get here? I have 46.30 divided by 32.07, and my magic number is 1.4437 moles of sulfur. Now I want to set up my ratio. Well, what's going to go in the bottom? Well, the one that's the smallest, which is the smallest, iron. So we want to set up a ratio of moles of sulfur per mole of iron, meaning I want to take 1.4437 moles of sulfur per 0.90778 moles of iron. And when I do that ratio, what do I get? I get 1.59. That's nice. 1.5903, we'll say, moles of sulfur per mole of iron. All right? Cool. All right. So what do we do? Can I round that to 2? Can I round this to 2 to 1? No, I cannot. Can I round that to 1 to 1? No, I cannot. 1.59 is not close enough to a whole number. So what do I have to do? I have to take my 1.5903 per 1 times 2 over 2. And when I take 2 times that, I get 3.180 per 1. So, oh, not per 1, per what? 2 times 1 is not 1, 2. So that's 3.18 moles of iron per, not moles of iron. Man, I really stink this day, don't I? Moles, but that has nothing to do with how poorly I'm doing with my writing. Yuck, 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 yuck. Good. So, can I round this? Can I say this is close enough to 3 to 2? And in this case, yes, that is probably close enough to say this is equal to 3 moles of sulfur per 2 moles of iron. Okay? And this ability to round this number, I mean, you gotta use judgment over time. Like I say, if that's 3.3, no, I don't round that. If it's 3.1, maybe. I mean, I round if it's 3.2, yeah, but in this case, it's close enough to say that it's a 3 to 2 ratio, which would mean what? Iron 2, sulfur 3 is my empirical formula. Got it? Cool. So that was a little more complex. You try this one, bring me back when you're ready. Well, here we go. I have potassium, chromium, and oxygen. I want moles of potassium. Moles of potassium are equal to 26.56 grams of potassium times 1 mole of potassium per, let's go to our periodic table, zoink, potassium, 39.10, 39.10, 39.10, 39.10 grams of potassium. So what do I get? 26.56 divided by 39.10, and I get 0.6792 928 moles of K. Good. How about moles of chromium? Moles of chromium equal 35.41 grams times 1 mole per, let's go to our periodic table. Where's my chromium? Oh, here it is. Looks like 52.00. If I go with 4 sig figs, 52.00. 52.00 grams. So here we go. Store 1, yoink. 35.41 divided by 52, and what do I get? 0.68096 moles of chromium. Cool. And the last one is moles of oxygen, which is equal to 38.03 grams of oxygen times 1 mole of oxygen per 16.00 grams. I know that one by heart. And what do I get? 38.03. Nope, 38.03 divided by 16, and I get 2.3768 moles of oxygen. Okay, now what do I want to do? Set up ratios. Which one is the smallest? Is oxygen the smallest? No. Is chromium the smallest? No. Is potassium the smallest? Yes. So I have to set up 2 ratios. Moles of chromium per mole of potassium and moles of oxygen per mole of potassium. And so this is going to be what? 0.68096 over 0.67928. We can look at that and guess what that's going to be, can't we? Oops, that's moles of chromium per moles of potassium. But we'll actually work the numbers, okay? And let's go with recall 2. I believe I have it there. Yes. Divided by recall 1. Oh, good. I did that well. And I get 1.0024 moles of chromium per 1 mole of potassium. And this is important to keep our units going, folks. And then recall 3 divided by recall 1 equals 3.499 moles of oxygen per 1 mole of potassium. Maybe I should put in the numbers here. 2.3768 moles of oxygen over what? 0.67928 moles of potassium. See? Good. Now, is this close enough to say this is a 1 mole of chromium per 1 mole of potassium? Sure is. That's certainly close enough to round. What about this? Can I round this to 4 to 1? No. Can I round it to 3 to 1? No. So what does that mean I need to do? I need to take my 3.4990 moles of oxygen over 1 mole of potassium. And then what I'm going to do, multiply the top and bottom by 2. We'll see if 2 works. Multiply by 2. What do I get? 6.998 moles of oxygen per what? 2 times 1 here. Per 2 moles of potassium. And I can round that to what? 7 moles of oxygen per 2 moles of potassium. 2 moles of potassium. Okay, here we go. So I have K, Cr, and O, right? Now, how many moles of K do I have? 2. How many moles of O do I have? 7. Now, Cr, well, what's my ratio up here? My ratio is a 1 to 1, but do I have 1 mole of K? No, I have 2 moles of K. So if I have 2 moles of K, how many moles of Cr do I have? I have 2. So it's K2, Cr2, O7 is my empirical formula. Make sense, ladies and gentlemen? All right. Let us move on to the last concept here. And in empirical formula, which is really no longer empirical formula, it is molecular formula. Consider a compound with the empirical formula BH3. It's my empirical formula. It's given here. If the molar mass, they're giving me a molar mass of the compound is 27.67 grams per mole, what is the molecular formula? Well, that looks like something new. It is. Here we go. Let's go back to our notes, and we want to go with calculations, and let's go with some calculation down here. We got to go all the way down here. Holy moly. Oh, look at this. I'm still not to the bottom. Woo! There we go. Molecular formula. We want to talk about how do you do calculations with molecular formula. And the first thing we want to do is define it, right? What's the definition of a molecular formula? Remember, our empirical formula was a smallest, let's go up here, what's the empirical formula? Smallest whole number mole ratio. It's the smallest whole number mole ratio. Now, for my molecular formula, it is the formula for the actual compound. Meaning it is not a ratio, it is what the molecule is actually made of. So if I say H2O, that means what? There's one oxygen and there are 2 hydrogens on it. It is not a ratio, it is the representation of the actual molecule. So a molecular formula is a representation for the actual molecule, not a ratio. Now, how do I calculate those? Process. What's the process? This is pretty easy. Okay, number 1, we have to determine an empirical formula. Now, sometimes we're lucky and they're given to us, and other times we have to calculate them, but we're good at that now. Number 2, we want to determine the molar mass. Let's write down determine or calc. Calculate the molar mass for the empirical formula. So we figured out what the empirical formula is in number 1, and now we're going to get the molar mass for that empirical formula. Number 3, we're going to calculate a factor. And what is this factor equal to? This factor is equal to the molar mass for the compound, the real molar mass for the compound, divided by the molar mass for the empirical formula. You got that? Okay, this thing is from number 2, right? Where did we get this from? Well, the molar mass for the real compound is usually given. It is usually given in the problem. So they usually say, hey, the real molar mass is this. Okay, so we know what that is. Good. And then what do? We're going to take the factor and factor times the subscripts in empirical formula. And that'll give us our molecular formula. Okay? It's really a piece of cake. This is easy. You ready? Think you got it? Determine empirical formula, molar mass for empirical formula, calculate our factor, and then multiply by subscripts. Here we go. Empirical formula. Yoink. BH3. So I want the molar mass for empirical formula. So what am I going to do? I'm going to take molar mass of B, 1 times the molar mass of B, plus 3 times the molar mass of H. And what's that equal to? Let's go up to our wonderful periodic table without which we could not live. Boron, 10.81. 10.81. 10.81 plus 3 times 1.008. And what do I get? 1.008 times 3 equals plus 10.81 equals 13.834 grams per mole. Good. The molar mass of the compound, what is that? Hey, that is a given, so what do I think it is? That is my actual molar mass, right? That's the actual molar mass for the compound. So what am I going to do? I'm going to calculate my factor. How do I get my factor? I'm going to take my actual molar mass, 27.67 grams. I'm going to divide it by my empirical formula molar mass, 13.834 grams. And what do I get? How about 2.00? So this is going to be 2. That's my factor. Now, how do I get my molecular formula? I take my empirical formula, BH3, and I'm going to multiply those subscripts by my factor of 2, yoink, and when I do that, what do I get? I get B2H6, and that is my molecular formula. Woo! Can't be easier than that, can it? All right, you do the last one, and then we're done. Bring me back when you're ready. Compound has an empirical formula. It is CH, so I want to know the molar mass for my CH, and that's going to be carbon. What's my carbon? I think it's 12.01, but let's look it up here. Let's clean this up. 12.01, good. Molar mass of carbon is 12.01. 12.01. What's the molar mass of hydrogen? I kind of just said it last time, but we'll make sure I'm right. 1.008. Yes, it is indeed 1.008. 1.008. And when I add those together, what do I get? I get 13.018. Let's make sure we can add 13.018 grams per mole. Good. What is the molar mass of the real compound? My molar mass of the real, it says if the molar mass of the compound, that means my actual molar mass, right? Is 78.11. I want to calculate my factor. And it's 78.110 grams per mole over 13.018 grams per mole. By the way, if you find out you're getting a fraction here, what's What's up there? Well, you made a mistake. Either you didn't calculate your empirical formula correctly, or you have the ratio mixed up. Your empirical formula mass is always less than or equal to your molecular formula mass. So you should never get a negative number. I mean, not a negative number, a fraction. 78.11 divided by 13.018, and I get 6.000. That's my factor. So what am I going to do? CH, and I'm going to multiply the subscripts here by 6, meaning I get C, 6, H, 6. Hey, wunderbar. And that will be all for us today. Got it? Ciao, Belle.